Hello. Today we will be talking about slope, pretty much calculating slope and describing it. Over the next couple of days we'll get into slope as a rate of change with its applications. But first we need to understand how to calculate it, what the different types of it are, the descriptions of it are, those types of things. The slope of a non-vertical line is the ratio of vertical change, the rise, which is called the rise of the function, to the horizontal change in the function, which is called the run. Again, vertical is up and down. Horizontal is, you can just call it sideways, I guess. In order to calculate the slope, we need 2 points, and we'll use this formula. M is equal to y2 minus y1 over x2 minus x1. So if we look at that here, with our example here, x1 would be -3, y1 would be 5, x2 would be 2, and y2 would be 1. I just number them. The ordered pair that comes first, I make my 1, and the ordered pair that comes second, that becomes my 2. So in order to calculate the slope, I have m is equal to y2, which is 1, minus y1, which is 5, all over x2, which is 2, minus x1, which is -3. Now, in the denominator here, we have minus a -3, so we know that we can change that to plus a +3, which helps our simplifying. 1 minus 5 is -4. 2 plus 3 is 5. So the slope going through -3, 5, and 2, 1. Ooh, I'm sorry. I said 5 but wrote 4. It's -4/5. -4/5. So that's how we calculate the slope. You can use that formula every single time. Now, classifying slope. A positive slope will look like this. And that's called it that it rises. It rises as you go from left to right. A negative slope, like we just saw with the -4/5, it falls as you go from left to right. This line would have a negative slope. Okay, so we have positive and negative. Those are the two ones that we're typically most comfortable with. Now, a slope of 0. Now remember, if we go back to the definition of slope, it's the ratio of vertical change to horizontal change. So if there is no vertical change, if we have just a straight horizontal line, okay, there is no vertical change. I go straight across on this number line the entire time. There is no vertical change. That has a slope of 0. Okay, and again, our definition is for a non-vertical line. So slope that is undefined is actually a vertical line because it does not fit into our definition. Vertical line has undefined slope. Slope of 0 and undefined slope are not the same because remember, 0 is a number. This could be 0/4. That's a number. Okay? Undefined, we got nothing for it. Nothing. So let's take a couple examples here, and then we're going to state whether they rise, fall, if they're horizontal or if they're vertical. Okay, so if we use our formula, m is equal to y2 minus y1 all over x2 minus x1. Let's label x1, y1, x2, y2. Label them there like that. y2 is -6 minus -4 all over 1 minus 3. This becomes plus a +4. -6 plus 4 is -2. 1 minus 3 is -2. This simplifies to a slope of 1. Okay? That is positive, so this rises because it's positive. Second example. Okay, x1, y1, x2, y2. M equals y2 minus y1 all over x2 minus x1. Substitute in. Y2 is 5. Y1 is negative 1. So we have 5 minus negative 1. X2 is 2. X1 is 2. Minus a negative becomes plus a positive. We get 6 over 0. 2 minus 2 is 0. That's undefined because we cannot divide by 0. So that means this is a vertical line. And we actually know where that vertical line goes, because if we come back up here, vertical lines have the same x value. So this is actually the vertical line x equals 2. That's the vertical line that we have right there. And the last type of example that we'll see today is determining whether the two slopes are of parallel lines or perpendicular lines. Parallel lines are typically the easiest to identify because parallel lines have the same slope. What that means is their m equals m. So parallel lines have the same slope. Perpendicular, as we get more examples under our belts, we will be more comfortable with them, but initially it is a little more difficult to identify. But the slopes of perpendicular lines are negative reciprocals. So that means that m1 is equal to the opposite of 1 over m2. So I have the reciprocal equal to the opposite of it. So the other thing that we can think of with that is that m1 times m2, that should be equal to negative 1. Okay, that's another way to think of it if that's a little bit easier to. If you multiply the two slopes together and get negative 1, then it will be a perpendicular slope. And these should be our last two examples here. We're going to determine whether they are parallel or perpendicular. So L1, okay, remember our slope formula is m is equal to y2 minus y1 all over x2 minus x1, just so we don't have to write that out each time down here. So line 1 right here, negative 1 minus 3 all over 3 minus negative 3. I get negative 4 over, it's negative 1 minus 3 is negative 4. I get 3 plus 3 gives me 6. This simplifies to negative 2/3. All right? So now we check out line 2. We have to find the slope there as well. So this is M2 because it's for line 2. Here I have 3 minus negative 3 over 2 minus negative 2. 3 minus negative 3, it becomes plus. There we get 6. 2 minus a negative 2 becomes 2 plus 2. I get 6 over 4, which simplifies to 3 over 2. Now, if we took negative 2/3 times 3 halves, we would get negative 1. And if we notice, if we flip 2/3, or flip 3 halves, we get 2/3. And then take the opposite, we get negative 2/3. So these are opposite reciprocals. These are perpendicular. Okay, those are perpendicular right there. So let's try the same thing over here on the right. M1 in this case will have 4 minus 1 over 3 minus negative 3. 4 minus 1 is 3. 3 minus a negative 3 becomes 6, and that's 1/2. All right. And lastly, we'll do line 2 over here on the right. I have M2 is equal to 1 minus negative 3 all over 4 minus negative 4. Minus the negative 3 becomes plus 3. I get 4. 4 minus negative 4 becomes 4 plus 4. I get 8. 4/8 is 1/2. It looks like those two slopes are the same. These would be parallel.